Great. Good morning, everyone. My name is Virginia Batt. I'm the Channel Marketing Manager at Vision Technologies. I want to thank you for joining us today. It's our 5th presentation surrounding the life cycle of a DAS project. So today we're going to be discussing OEM product selection, and more specifically CommScope's Intelligent Optical Network family. Our presentation will last about 30 to 35 minutes. Your phones are muted right now, but if you have questions, please don't hesitate to use the question box on the side of your screen. We have a lot of content to cover today in a short amount of time, so we're not going to be answering questions during our live presentation. Instead, at the end, we're going to provide you with an email address to contact us with any additional questions you have. So I'm not going to go over these slides in too much detail. These are both corporate snapshots, this slide and the next slide for CommScope and Vision Technologies. Since we're mid-series, these may be a little bit redundant, but if you're joining us for the first time and you want additional information, please let us know, contact us, send us a note, and we can certainly follow up with you. So today I want to welcome Ron Pockus from CommScope. He will be presenting for us. He's a wealth of knowledge, drawing from both of his experience working with carriers and integrators, and also his current position with CommScope focused on in-building wireless solutions. Unfortunately, Rick Baldessari will not be joining us today, but I did want to include his bio information and email address, so if you want to contact him directly, feel free to. At this point, I'm going to turn it over to Ron. He's going to go over our agenda for today, and welcome.
Thank you, Virginia. Appreciate it. Welcome, everybody. I'm trying to find Virginia so I can mute her. Okay. All right. Well, thanks, everybody. We have a lot of information to cover, so let's dig in. The agenda today is basically to give you an overview of the different products that CommScope offers that are all referred to as the Intelligent Optical Network family. So I'm going to give you a snapshot of the Eyeon B, the Eyeon U, and the Eyeon E today. As far as what we've covered so far, this slide here and these slides will be available, gives you access to all of the information that we've covered up until this point in time. So the topic today, I'm referring to it as a matter of choice in terms of the proposed solutions. We've already told you about CommScope in the past. We've been doing this for several years, as in 20 plus, and the one thing that we've learned over and over again is the fact that one size doesn't fit all. There are different requirements for different individuals. Buildings have specific requirements. So because of that, we offer a family of products based upon your specific requirements. So that would be the Intelligent Optical Network family. That's the Andrew family of distributed antenna systems, and I'm going to cover each one of these from a very high-level point of view, and we'll be providing you with links to get much more detailed information as well as any questions that you may choose to send us. So the Eyeon B is the product that we've had out there for the longest period of time. It's a very, very simple process in terms of how it's developed. We have an RF source over here on the left that feeds the DAS. Then we have a master unit which is going to sit typically in a closet. And the information is basically there's cards that will go in there that I'll share with you in a minute. We basically consolidate all the signals into this master unit. We convert it from RF to light. We go down an optical transport of single mode fiber out to remote units where everything is converted back from light to RF. Then we go down half-inch coax to antenna points. So that's the traditional product that we sell every day and have been selling for a number of years. This slide just shows you some of the cards that go into that master unit. The TPOI card is basically each one of the carriers will have one or more of these, and this is their point of interface to the DAS. The next card going from left to right is basically a splitter combiner card. These cards here, the TFLN cards, those are our optical cards. So each one of these cards supports up to 4 of these remotes. So that's pretty much how it's set up. It's pretty simple. One of the things that people like about the Eyeon B is the simplicity in terms of being able to add different carriers. So if we started off with a neutral host system that had Verizon only, and then we just wanted to add AT&T, for example, all we have to do as far as touching the system is we have to go to the head end, to the master unit, and we have to put a TPOI card in or multiple TPOI cards. So it's very, very simple to scale this product and to add. So what are the benefits of the Eyeon E? Proven technology is certainly at the foremost. It's very, very highly scalable. As I showed you in the previous slide, it's easy to add additional carriers with minimal interruption. It's extremely reliable solution, and it's our most cost-effective solution from an equipment perspective. So that's the benefits of the Eyeon B. But what if, and this is our second option, what if we have multimode fiber and not just single mode, and it's dark and we want to use it? You know, what if we want to have a more simplified and a more accelerated deployment process? What if we're looking for a more cost-effective installation? A typical installation of an Eyeon B or any of the traditional products requires some pretty expensive folks on site to keep everything tracking. And what if we have a mixed RF environment and we would have the need for both low and high-powered remotes? What's a mixed RF environment? We may have a building that's a leads building, so it's blocking the signal from the outside, and yet in certain areas there may be macro cells right on campus. So all of that taken into consideration, the signal going into the building will be different depending on the floor we're on. And what if we need to have more control of the carrier signals coming in from, in this case, a typical base station due to the high amount of traffic and be able to manage all that traffic? So if all these what-ifs fall into your list of requirements, the product that we recommend is called the Eyeon Unified Platform, or the Eyeon E. So what we've done with this unit is, first of all, we've cut the headroom down on the head end itself by about 50%. So if space is an issue, that's a great fit for you. We're talking about this in terms of reduction in skilled labor because of the intelligence that's built into this, and this is all embedded into the system. It's not necessary to have a very, very high-level, highly experienced RF engineer when a lot of the stuff can be done basically plug and play. So some of the intelligence built into it is a system configuration tool. What this gives you the ability to do is actually to take a design that was done, be able to download that design into the Eyeon U platform, and then it will create for you a bill of materials, elevation drawings, schematics, all of that stuff in a matter of minutes. This task today takes a matter of days. Some of the other intelligent things that it offers is system optimization tool, where if we're doing base stations, we can actually test the base stations prior to them being on site, and instead of the traditional way of testing each carrier, we can actually test all the carriers in a single pass. So it's very, very, intelligence is the name of the game for this product. So what does it look like on the head end? Not a whole lot different than the other unit. It looks bigger, but it actually ends up taking less space. So the IPOI sub-rack at the top here, that's basically your TPOI cards. We've just consolidated them into a rack. The sector matrix sub-rack has to do with how am I going to deal with sectorizing if I'm going to set up zones and things like that with the different carriers. And then as I mentioned in the requirements, we have both a low power and a high power sub-rack. so that we can support multiple flavors there, and then the power distribution subracks. There's two, this is just an example of the IONU's low power units. One of the interesting things too is it's also outdoor rated. So if you have a situation where you're needing to improve service both indoor and outdoor, the IONU is a good fit for that. If you wanted to update the system to a MIMO configuration, in the past that would typically be 100% uplift. We're able to cut that in half. LC APC connectors to keep it nice and simple and make sure everything is going smooth. So we also have a high power remote as well. So what are the benefits of the IONU? If we have a situation where we have both single mode and multi-mode, and we'd like to use a combination of that, then the IONU is a perfect fit for that. If we're really looking for an accelerated and simplified deployment, the IONU again fits that requirement. And from a more cost-effective installation, because the IONU is intelligent, a lot of the steps and a lot of the troubleshooting and everything, we can accelerate the installation cycle. If we accelerate the installation cycle, it costs less. I mentioned the fact that we have both high and low powered remotes. The last one is really, really key, and that's carrier sectorization on the fly. Just going back, we talked about sectorization before. Sectorization is being able for the carriers to kind of split up their signal so that they can send different feeds, and the reason for that is they want to keep that data speed as high as possible. The way that typically is set up on a traditional system, for example, the IMD, you have to actually go in, and it's a hard wiring configuration to do that. The nice thing about the IONU, based on the intelligence that's built into it, is all of that is done through software. So it's very, very simple to set it up, and it's very, very simple to change it if you like. So huge, huge flexibility that we've never seen before in any other products on the market. Okay, but with all that being said, and with the industry being over 20 years old, here we sit today with still, all this square footage of land available today, and yet our penetration rate in the business is currently only about 2%. So the question is why? And we've done some analysis of it, and we found out, first of all, the traditional DAS is a standalone infrastructure. By that I mean it's something that is really not part of the building's infrastructure setup. The fact that it's very, very cumbersome to work with hardline coax and very slow in terms of deployment. Since in an enterprise world, the network folks typically have to manage the system after it's deployed, that we get a lot of pushback from the network folks saying, why do we have to manage this thing? It's an unknown. The fact that a lot of the systems out there traditionally have lack of flexibility. And we get into the deployment situation. It's typically highly disruptive, and it takes a long, long time to get everything squared away. And very, very key, this last slide, this last bullet here, the high cost of traditional deployment. Typically, the labor cost is 50% of the equipment costs. So those are some of the reasons why we haven't seen more activity out there in the enterprise world for distributed antenna systems. So what if, back to our options, this is option number 3, we have both single mode and multi-mode fiber, kind of like with the IONU. We're looking for a more simplified and accelerated deployment process, something that's more like Wi-Fi, if possible. We're looking for a more cost-effective installation. And our preference is to take advantage of existing IT infrastructure. And another preference of ours is, can we leverage this deployment with other IP applications? And the solution to all of those is a product called the Eyeon E, which is our unified wireless infrastructure solution that basically can tie together both wired and wireless networks. So the design criteria for it is, let's make it simple, let's make it scalable, and let's make it flexible. And all of that is, the end result to all of that is going to be a reduced cost of ownership. So there's three key values to the product. On the far left here, from a frequency perspective, we go anywhere from 380 megahertz up to 2.7. From a multi-operator, multi-technology point of view, we cover all these technologies that are currently out there, and this is a world product. This product is offered all over the world. And then from a standard IT infrastructure, we're able to use not only single mode and multi-mode fiber, all pre-connectorized, but also Cat 6A for our horizontal runs. So the three basic components, it's very, very simple. On the left is the CAN, which is our central access node. It's very much like the master unit in the U or the B. And that's going to basically be it's going to interact with all the different signals that are going to come into us. And we have cards that support that. The 10 is actually a transport expansion node. It's very much like a remote, if you will. And that's going to sit out typically in a closet. And its function is not only to sit out there, but it's also going to provide power via PoE out to the antenna points, which we call our universal access points. Each one of these universal access points not only supports traditional cellular coverage, but it also has an additional port where you can use another device such as a camera and things of that nature. So again, it's very, very simple. I'd kind of walked you through this already. We've got the CAN here. Then we go out on fiber to the transport units. And then from there, we basically are going to go out to the antenna points. Very, very simple. You see here an example of where we've got IP phones actually plugged into the access points. So again, looking at it over on the right here, we've got in this case, we're using a base station. The EPOI is something we didn't really talk about, but that's our interface module, if you will. So we'll connect up to that CAN, which is going to be sitting at the head end. And then from there, these red lines here are all fiber, either single or multi-mode fiber. And then that are going out to the 10, which is our expansion hub. And then from there, the blue lines here are all traditional structured Cat 6A going out to the access points. So we have one antenna. It's basically, it can be either wall mounted or it can be ceiling mounted. And it's, again, our whole premise here is to keep it very simple. So what are the benefits of the Eyeon E? It's very flexible because it can use both single mode and multi-mode fiber. It accelerates the deployment process because of the intelligence built in it. What's an example of that? When you actually connect one of the UAPs, it automatically populates the controller and numbers it so you know exactly what's going on. So you don't have to sit down and figure all that out. It's a very cost-effective solution using existing IT infrastructure. So if there's Cat 6A there, that's a wonderful thing. And it's 100% PIM-free. It's the only product we have that is 100% PIM-free. Passive intermodulation is becoming a huge issue out there today, where we're actually having interference issues with some of the passive components in a traditional DAS. So because the Eyeon E is designed from the get-go, it's totally digital, it's 100% PIM-free. So the carriers are very, very excited about that, and they see that as a huge benefit to our offer. So in summary, it's all about choice. You know, there are certain things, you know, so if I've got single mode fiber that I want to use, that I would like to use in my infrastructure for transport, any of our products will support that today. But we've run over and over again into lots of multi-mode fiber out there, and in the past have not supported that. We now have the ability to support that through either the Eyeon E or the Eyeon U. Antenna placement above the ceiling. You may have situations where the antennas need to go above the ceilings. If that in fact is the case, then the IMD or the AINU are your best fits. If you have a preference to use existing infrastructure, Cat6a specifically, the Eyeon E is your perfect fit. If you have the need or requirement to have flexible software-driven sectorization, again, being able to change all of those things on the fly, then that's a huge advantage of the Eyeon U. If you're looking for a 100% digital solution, the Eyeon E is the way to go. And if your ambient signal out there requires the use of both high and low powered remotes, the Eyeon U is a perfect fit for you in that case. So our next session will be on DAS deployment, and that will be October 20th, 2015. And again, we have one of the things we're sharing with you down here under more information. If you'd like to get a little more details on the Eyeon E or the Eyeon U, we have links to YouTube where we can provide you with additional information. So I am going to unmute Virginia. Virginia, do I have you back? Okay.
Appreciate it. You've shared a lot of information, and we certainly do want to make sure that we've provided plenty of additional resources for you, as Ron mentioned. There are YouTube videos. There's also a DAS-Cell site, which has more information on DAS and in-building wireless. As I mentioned, we're not going to answer any questions over the live presentation. However, I did want to share this last slide with you. If you have any extra questions, this is dasinfo@visiontech.biz. Certainly feel free, whether it's a generic question or you'd like to talk to Ron more specifically about the U, the B, or the E Eyeon solutions. Certainly feel free to email us and we will respond back to you. We'll also be posting this presentation and recording if you've missed any portion on YouTube, and make them available with our other previous presentations. So lastly, just again, hopefully we will see you on October 20th, and I think that's it. So I hope everybody has a great day, and thank you for joining us.
Thank you. Please